right, thanks. Thanks for everybody for joining today. My name is Richard Threlkeld. I work for AWS Mobile, and I'm part of the AWS AppSync team. We are going to talk today about this new service that we launched at reInvent in 2017. And this is managed GraphQL as a service. It's got real-time capabilities for operating with data, such as data coming from DynamoDB. It also has offline capabilities so that your data can be not only persisted offline, but it's got a full programming model to where you can perform modifications to data, such as CRUD type style operations offline when it comes to GraphQL mutations. And finally, I'm going to touch upon some of the enterprise security features of the service today as well, such as enabling fine-grained authorization when you're using AppSync to communicate with your backend data services. So before we get into this, what are some of the offline and real-time use cases that you might be experiencing in your company when you're trying to build applications, right? So the first is today's day and age. Most users try, when they're connected online, they expect data and just kind of information to happen and get communicated to them immediately. So this could be banking alerts, such as people that, transactions happen on their behalf, maybe from someone else in a shared account, or if there's maybe fraud or something else. This could be news stories, like I'm looking at a new real-time news feed and, a celebrity or a political member makes a new statement about something and you want to get alerted on it as soon as that happens. These could be simple chat applications, like somebody's going to try to talk to you and you want to know about it when it happens, or it could be some of the emerging experiences, such as shared collaboration style apps, or even AR and VR experiences, to where maybe multiple people are in an educational setting and someone that they're collaborating on something with has made a change to a 3D image or a model or something else, or even an immersive experience to where you want to see that happening immediately when that other person makes the change. What's interesting about some of these use cases is at the same time, in today's day in society, we still travel and we go all over the place, and we might be in the subway where there's limited connectivity, if not any at all, or in a geographic region where the infrastructure's not set up to get all of this data and rich content immediately, or just could be going between multiple locations with Wi-Fi that's on a shared medium and our connection goes on and off, right? And this is kind of pushed the need to have data available when it's offline as well, right? Because if I am on that subway, I want to be able to read my news stories, or even I might want to still look at my previous conversations from people and answer them, so that it's optimistically sent when I come back online that they'll receive that message. And what's interesting as you start talking to your own customers about some of these use cases, or even some of the data lake type use cases around this area, these scenarios that you're talking about, they're basically one and the same, whether they're online or offline. It's just the functionality of them differs a little bit. So what is this service, AWS AppSync, and why are we talking about some of these use cases today? Well, this is a managed GraphQL service, and the idea is that you can leverage the GraphQL data model that I'll talk about in a moment to give your applications both these real-time and offline capabilities. Rather than having a built-in database into the service, we actually allow you to connect to AWS resources in your own account. So right now the service supports Amazon DynamoDB, Amazon Elasticsearch Service, and AWS Lambda. And when you're using these services, that means that you have capabilities both offline as well as real-time when you're connecting to those data services. And since you're using Lambda, that can actually be proxies to things like Aurora or MySQL on RDS, or any other data service in AWS that you can access via a Lambda function. And what's interesting about this is you can make any of these real time by just going through the AppSync layer. So if you wanted to know about changes to data, or when something happens and a Lambda function is invoked, you can kick that off through AppSync, or it could be just reads and writes going from a DynamoDB table. You can subscribe to data there. Those same data responses through the GraphQL programming model are also persisted on the clients so that you can make changes to them or just have them in read-only mode. The other thing is, since we're dealing with offline use cases as well as collaboration with applications, like the data could be shared across not just a person with multiple devices, but multiple people across multiple devices. When this happens, right, data is going to inevitably end up in some sort of conflict. and you'll need some sort of conflict resolution to take place. Now, one of the advantages of using AWS AppSync is rather than pushing this development process off to the client developers and then managing versions of client applications and so forth, you can take advantage of unique cloud capabilities with AppSync so that you can do that conflict resolution process and custom business logic in the cloud when you want to handle different versions of data that come in. So I'll talk about this a little bit more. The other thing that's really important as well is we've built in some enterprise security features with AWS AppSync. So we support out of the box API keys for getting started and simple applications. But you can also leverage both AWS IAM with AWS credentials in the key of access key, secret key, and tokens, even short-term credentials from Amazon Cognito Federated Identities, as well as Amazon Cognito user pools, which supports OIDC style tokens. So ID token, access token, refresh token. And you can use AppSync to set permissions at GraphQL field level operations, so things like queries and mutations and subscriptions. But you can also thread this identity and context all the way through to GraphQL calls that are invoking resolvers. So you can do scenarios like if people are creating a blog post or a CMS style system, maybe everybody can read all blogs and even create new posts, but only the owner or the author of a specific post can edit or delete them. And you can do a lot of other fine-grained filtering and mutation-style operations that I'll talk about in a little bit too. So before we get into those details, some of you might not be familiar with all of the pieces of GraphQL. So we're going to do a little bit of an overview here. So first of all, what is GraphQL? Well, this is an open declarative data fetching specification, right? So this is an open spec. It's not necessarily an implementation at all. The other thing to realize about this is because it's an open spec about data fetching, this is, first of all, not a graph database. You can actually use any sort of backend for persisting your data to a store. This could be NoSQL databases like Amazon DynamoDB, could be relational, as I mentioned before, could just be generic HTTP or some sort of object storage. And the idea behind GraphQL is, from a high level, if you were to look at traditional data fetching with RESTful backends that you would maybe connect to from your mobile devices, you might create a blog post system where you enable an endpoint to get all blog posts. And let's say that I do that. So my client goes to this one RESTful endpoint. It gets back a list of posts that are available. But if I want to get information on those posts, it's going to return to me a list of IDs, like ID 1, 2, 3, all the way through N. And then I have to, one by one, return all of those IDs to a post info for a specific post to know information about it, right? Like I want to get the title and the author and all that other jazz that goes along with a blog post. But maybe my requirements changed a little bit, and I didn't need to just get all of the things like the content. I just want to know like the titles of all the posts. Well, what you would do now is I'd either modify query strings or something else, and then I'd just expose an endpoint like post just by the title, or maybe post just by the author. Or I wanted to be a little fancy and I did things like post names starting with X. And then for each one of those posts, they might have multiple comments on them. So now I need to have a specific endpoint for all the comments on a post, and I need to iterate through that. And the problem kind of gets exponential, especially when you have different security permissions on all of these different resources. GraphQL works a little bit differently. Instead of the implementation and what gets returned to the client being encoded on the back end, the client actually sends its request over the network one time. The service parses this request. It goes and fetches the required data from one of the data sources in the back end and returns it in that single network round trip back to the client. Let's talk about this in a little bit more detail. So how does this work? Well, when you're using GraphQL, the first thing you start with is you model rather than the network resources, you model the data in your application state of what you need to provide to either your mobile or web applications, or any application for that matters, right? It could be some sort of IoT app. And you do this with a schema definition language, or SDL for short, that looks something like you see on the screen here. So the first one is you would do what's known as a user-defined type, and that's my to-do type here. I want to create a to-do app. And in this to-do type, I use very simple fields that are like IDs, names, descriptions, and I give them specific types like strings, ints, and so forth. GraphQL has a reserved ID type, and that can either be a number or a string, as you see here for my IDs. And if you put an exclamation point, that means it's a required field. Otherwise, the other fields can be null. The other thing that you see here in this GraphQL schema is a type query. Now, there's three top-level operational types that GraphQL exposes. The first one is what's required of every schema, and that's a query type. And this is essentially what you operate from the clients with when you're going to fetch data. And so what I'm saying is I want to expose a query type called getToDos, and I want it to return a list of to-dos. That's what the little brackets around the to-do mean. I could also have type mutation, or I could have type subscription. Mutation would be for changing data. Subscription would be to subscribe to real-time data. We'll talk about those a little bit more as the demo goes on today. So then what happens after I've published this in my GraphQL schema for my API, clients just send this request over the network, and it looks exactly like you see here. I do query, getToDos, and I specify the fields that I want to come back. Notice that I only specified ID, name, and priority, right? Whereas I could have also gotten description and due date. This is one of the GraphQL benefits because the client is actually requesting the data it needs, the shape of the data as it's going to be returned to over the network. So what the service then responds with is just those specific fields for that data set. So I can get just a subset of JSON returned to me on the right, and I can do it all in one network round trip. It's very friendly from a mobile standpoint when it comes to bandwidth and everything else. So what do you see when you do some of this? What are some of the benefits? To start off with, when you have a system like this, you get really rapid prototyping and introspection of data and self-documenting features built into your API for fetching data over the network. People can come in day one, they don't need to know anything about your implementation of the back end, and they can just start walking through your GraphQL API from a client standpoint and specifying the data that they want to come down to and iterate quickly. The other interesting thing is from an application developer standpoint, I mentioned before that the implementation isn't encoded on the back end. So in your literal project, like I'm building a mobile app in iOS or Android, or I'm building something in React Native or React or Ionic or maybe Angular, I can actually in my client project specify those GraphQL queries and mutations and subscriptions, and I as the developer say which pieces of data I want to fetch at which time, how I want them to be shaped when it comes over the network, whether or not it happens always or just during a query rather than a mutation, and what specific data I want to be presented to me in a real-time manner with GraphQL subscriptions. So you get this fine-grained control with batching, request response in real time, and it also solves some of the network chattiness features of just kind of sending everything over a WebSocket all the time and spewing data all over the place. The other interesting thing there is you saw one implementation or one side of an N+1 problem with GraphQL to where the client doesn't need to request data multiple times over the network. There's a related N+1 problem on the back end I won't go into too much detail about today, but rather than having to fetch from your backend data sources multiple times for aggregations of data, we've got a process similar to an open source tool called Data Loader that runs in our Lambda resolvers, which is called batch invoke, that you can return multiple results in a single Lambda function that's running as a resolver. So you can essentially solve the back-end sub-nested query problem as well. So what I'm here to answer today is, and what we tried to answer with this service in general is, can you do real-time with GraphQL? Can you do batching? Can you do aggregations? Can you do relations on data that doesn't come from a non-relational database, right? Just with NoSQL. Can you do features like search? Can you do features like offline? And with this service, we really want to answer yes. You can do all of these today by leveraging AWS AppSync. So how does this work? What's the flow of the service? Well, what you do is you create and upload a schema to your service, and that's through the schema definition language that I showed you there before. And then you connect to different data sources. Now, there's a few different flows to connecting to data sources. You can create one from a sample schema that I'll show you in a moment. You can create one from scratch, in which case you can manually wire up all the data sources. Perhaps the more interesting flows, though, that AppSync supports is you can just write your schema definition language and press a Create Resources button. And the resources in the back end, like DynamoDB, will be automatically created for you. So you don't need to worry about doing that. We've also got the reverse flow, which is you can take an existing DynamoDB table and point a data source at it, and you can import from there. So we will essentially get the description of the table and the details from it that we can infer, and then we'll automatically build out a schema for you. And at that point, you can modify the schema if you like to. But basically, if you create this schema, and whether you're wiring up data sources manually or auto importing them and creating them, from there, clients can just communicate as they wish. They can get data when it's offline, get data in a real-time manner. It's up to them because it's in the application developer's hands. Okay, so let's talk about the clients a little bit before we jump into the service. So the first is that the way AppSync works is we integrate with the very popular Apollo GraphQL client. So we provide full SDK plugins for JavaScript ecosystem, for Android, for iOS. And the JavaScript support works across both mobile web, so React, Angular, and so forth, Vue, as well as the hybrid style framework. So this would be React Native and Ionic. You can use the same programming model across them in the same SDK plugin for the Apollo client. This gives you offline support, so your data is automatically persisted offline for queries, and then it's an optimistic UI with a write-through cache for mutations. This means that from a latency perspective, you're immediately reading and writing to the local disk that's persisted on the device dependent on the platform, and then the fetch happens over the network asynchronously. So this is a nice way to get a really snappy UI without worrying about device to cloud latency. The other thing is that we give these conflict resolution features. So we give them in the cloud, but we also do give you an optional client-side callback if you do want to add some extra features to your client, like maybe you want to do client always wins or something like that. And then, of course, our clients with the plugin to the Apollo client support full GraphQL subscriptions. So we have a Handshake process for doing authorization to subscriptions. It's an event-driven model, and then our SDK does all of the negotiation needed for automatic WebSocket connection. So what does offline data rendering look like in a programming model of something like this? Well, the first is you create the AppSync client, and you have to pass it in some details, such as the endpoint, the region, and the authorization type. I'll dive into this a little bit more. One of the things that we've done, though, is we've integrated with a library that we released last year called AWS Amplify that makes tasks such as authentication or analytics easier. And I'd urge you to check that out a little bit as well. I'll dive into this a little bit more in a moment. From there, since I mentioned earlier that we've integrated into the popular Apollo client, and in this case, I'm showing you a JavaScript example, but you can see from our documentation the iOS and Android pieces as well. But you'll notice that I basically pass this client constructor to the Apollo provider, and from there, your data is immediately available offline. We handle all of the heavy lifting and persisting to the local data source for you. You don't need to do anything else. So Amplify is this JavaScript library that you can use for front-end development. As I mentioned, works across JavaScript frameworks, both web as well as hybrid. And it gives you this nice declarative interfaces for these categories. So there's a handful of categories to begin with. You've got authentication, an analytics category, an API category, a storage one, and a cache one. The out-of-the-box implementation of the authentication category uses Cognito. So it uses both Amazon Cognito federated identities as well as Amazon Cognito user pools. So you can basically choose which one of those you want to use. And depending on which route you go, you can use those features inside of the AppSync SDK. So let's say that we wanted to build out our own custom UI and use it with AppSync for people logging in. I would use the authenticator component with React for Amplify, which allows you to scaffold out your UI and make it very custom. You can do MFA with this either via SMS or email, and also it will track all things like refreshing credentials automatically for users. Then if I wanted to use this in AppSync, as I mentioned earlier, by default, we enable API keys, so that's the quickest way to get going. But when you are ready to integrate with Cognito and use AWS Amplify for auth, you can see if I wanted to use AWS Identity and Access Management with AWS IAM credentials from Cognito Federated Identities, I just use that auth category and get the current credentials from Amplify. If I instead wanted to use Cognito user pools, well, then I can just pass it an async function for the JWT token and get that token from the auth category as well by calling current session instead. The nice thing about the user pools functionality is that's what's going to allow you to use Amazon Cognito groups to logically group things into like admins and HR and so forth. And as I mentioned earlier, we thread this through as context so that you can do fine-grained auth, which I'll talk about. Before going into those details, though, let's suppose that you wanted to do both an optimistic UI as well as write data when you were in an offline state. Now, the first is to do optimistic UI. We do recommend that you set your Apollo fetch policy to be cache and network rather than just like network only, for example. And this allows you to do that write through read that immediately cache first read as well as the write immediately to the cache before sending data over the network. Now you could just set that if you wanted to, but if you do that and your network latency is slow, you won't see your UI get updated immediately. So in that case, you can leverage Apollo's optimistic response to pass your props through to a component, and now your UI is very snappy and gets updated immediately. If you wanted to update data when you were in an offline state, that's just another method that you need to call, which is this little update one that you see at the bottom. And you can do it at a fine-grained level. So if you only wanted to update one piece of your UI when you were updated, such as a view that corresponded to an all post query from a blog post, you basically pass that query through as a piece of data. You read the data off and you pop onto a stack the changed data in your application, and it'll immediately be available in a persisted offline state. So what's the data flow in a system like this, right? I mentioned there's data that's going from the client, and then when the service actually processes the data, it'll go through conflict resolution. It'll then speak to your backend data sources, and then it'll transform the data back into a GraphQL request and response when the client's going to get it returned to it. But there's a few processes that happen here, right? So the overall flow is if you start from the left-hand side, a client's going to get some sort of authentication data unless it's using API keys. It's going to form its GraphQL request and send it to the service, along with its identity information. The service then knows about the GraphQL request. It's translated it into the appropriate format for that backend service like DynamoDB or Elasticsearch or Lambda. And it's also threaded that identity information through into that request. Now, at this point, you could do some conditional logic that I'll show you in a moment here to say, if the user equals X, Y, and Z, allow it to win or to write through, otherwise fail it. Or you could allow the request to go through, and on the response from one of those data sources, then you could do something like filtering, right? So it could be when the response comes through, if the user's not in a specific group, don't allow it to return data to the client. Or maybe it's something a little bit more complex to where if the user is in one group, allow all data to go to the client. However, if they're in these other groups or not in any other group at all, maybe filter it so it's a subset of the data. You have this control with AppSync. So what does this fine-grained access control look like? Well, your flow would normally be, let's say I had a mobile device and I was going to authenticate against Amazon Cognito user pools, for example. I'd put in my username and password. Maybe I'm using AWS Amplify, as you saw in those code samples. I get some responses back, and then I make my GraphQL request. And let's say that I wanted to get some data from a database like you see on the right, and it's got like it's a blog post system again. Maybe it's a news system. Maybe it's something else. But it's keyed by ID, and not only is the data there, but the author of that item is there, and that could be a single author. Maybe this is a list of permitted viewers. Maybe it's a list of permitted groups. Maybe it's an attribute saying if it's public or private data. And basically, before I do that check, either on the write or the read, I could just do a very simple if statement. If the author is the username, all good, allow it to pass through. Otherwise, reject it and maybe even respond with a custom unauthorized message. Okay, great. Now that we've done a bit of an overview on these pieces, and you've seen both how the service works from an overview on both the client programming model as well as the backend, let's jump into a little bit of a getting started with AppSync here. So this is the main AWS AppSync console. And the way that you normally access this is from the console, or you could use CLI. But you'd come in and you'd come to this create API. So from here you can give a friendly name to your API, and you can either click a custom schema or a sample schema below. The sample schema that we have included comes with some nice demonstrations of all the power of GraphQL out of the box. So we call this the event schema because you would create events like I'm going out with my friends or weekend plans to where you've got these unique IDs that you could create. Also give it nice fields like the name of the event and where and when and a description. And we also demonstrate here, we've got a separate type of comments because you would comment on these events, like, sounds great, can't wait to meet you there. And from there, we also demonstrate some things like GraphQL connections, which essentially allow us to relate events to comments on those events through this comment connection that we've got here on this type. And additionally, we're demonstrating some things like pagination using GraphQL connections, which we automatically do in AWS AppSync and encrypt that data going down to the client in terms of pagination tokens. We're also showing GraphQL queries, mutations, as well as subscriptions. And with AWS AppSync, we provide a first-level GraphQL directive called AWS to subscribe. And this is an event-based model where when mutations take place and change data in your system, you can basically tell it which mutations will trigger a notification on subscription. So for example, in this case, I'm saying whenever a client subscribe to event comments, as you see here, this comment on event, because it's specified in this mutation directive, will fire that subscription and notify any of the client subscribers that a comment on a specific event has taken place. Now, this can be set up in a many-to-many relationship. So since this is an array, I could have multiple mutations invoking the subscription. I could have it in a one-to-one, or I could have the inverse flow, where I could have multiple subscriptions being triggered by a single mutation. In this case, what I'm going to do is I'm actually going to start from a custom schema, though, just to show you a few other features. And you can see when I immediately click OK, it's actually provisioned me from a warm pool, an API that's got my GraphQL endpoint ironed out in here, my API key. By default, these API keys expire after 7 days for protection purposes, but you can extend them up to 365 days. We've also got some sample applications down here at the bottom. So I've got iOS, web, and React Native. We just don't have in the console at this point Android, but we are adding that. And you can get the Android SDK from the AWS Labs as well. Then for each of these, we've got config files as well, including a GraphQL introspection schema that you can pull down. This just makes application development a lot easier. So rather than trying to figure out all your settings, you pull down the config file, add it to your existing project, and you're ready to go. Data sources can be added from this pane. So you could add a demo data source. I could select from multiple types, such as Amazon DynamoDB, Elasticsearch, Lambda. I could also select this none data source, which allows you to invoke what's known as a local resolver in AppSync. A local resolver can be used for publishing events if you don't want to modify a data source in response to a mutation. You can actually use a local data source and publish to it so that I can call a mutation, but it doesn't do anything except invoke one of the subscriptions for sending messages down to clients. You can also use it for transforming data in the cloud and concatenation type operations and things like that. If I were to pull a DynamoDB table, it would look something similar like this, and I can pull from a bunch of different data sources that I've got in here. If I come over to the schema page, I can use GraphQL SDL. To save my schema, and it immediately, just by saving that, will expose some of my types so that I can walk through everything from my GraphQL queries and mutations to see what's available to me. So this is an example of GraphQL introspection capabilities to where day one, if I don't know anything and I just have a schema, I can come into the system and start walking through the capabilities. But let's say that I wanted to do a new user-defined type. So I do type to do, give it a unique ID, a name, maybe a due date. And then again, I'm going to save this. Now you notice when I save this Create Resources button becomes available. If I come over here to Create Resources, I now have that user-defined type available to me. And it's given me some different GraphQL types here that I can go ahead and operate on. So if I change some of these, the schema down here will change correspondingly for my queries and mutations. I could also add sort keys. And if I wanted to, I could add indices as well. But for now, I just want to do a very simple by type. Click on Create. And this process will automatically create a DynamoDB table for me. It will wire up everything from my resolvers for both my queries and mutations, as well as publish my schema to my API so that I could operate on this data. Now you notice I'm just in the AppSync console. I haven't actually done anything when it came to creating DynamoDB tables or wiring up resolvers or anything like that. In fact, it actually created this to-do table for me, and this lives in my own account. So you can see I've got all of my DynamoDB tables in my own AWS account that are available here. I come over here into the queries pane, and I can start operating. So what I want to do is I want to do a mutation, and let's say I want to just give this a friendly name like put to do. I can do introspection on this, including autocomplete, so I'll do put to do here. Need to give it an ID, and I'll give it 123. I'll give it a name. And I'll also give it a due date with just 1, 2, 3, 4, 5. And what I want to return back to me, because it's GraphQL, is I just want to return back the ID. So I go ahead and run this put to do. It comes back to me, gives me the data that went to the database. And if I refresh my DynamoDB table, you can see it's actually here in my own account. If I wanted to get the data, I'll do a query. And actually, I'll just do a list operation for you here. So I'm going to do all to do. And what do I want to see in my database? I want to actually get back the name and maybe the due date. So now I list all. It's given me all of the information back in my database. And I could, of course, change this as I see fit. I'll put another to do, and now I'm going to list all. And it's essentially reading and writing from our database. So this is a quick tour of the AppSync console. Let's go back through a few more details before we jump into a more advanced demo. Okay, great. So we saw some of the features and functionalities of the service, and how easy it is to get started, as well as write and read data from one of the data sources like DynamoDB without actually having to go outside of the GraphQL world. Let's talk a little bit more about the client-side experience. So our SDK plugs into the popular Apollo client, which has a normalized cache that we have a persistent medium behind the scenes. And so we handle all the things like all the authorization routines and handshaking there, as well as persisting the data to different offline stores. So on the case of web, this is going to be local storage. On the native platforms, we're going to persist to SQLite. On hybrid platforms, it kind of depends. It might be SQLite, or in the case of iOS on React Native, I believe it happens to be a local JSON file that's written to. And this gives you capabilities of not only being able to have all of the offline features, but you can also do things like pre-cache data before you send data to the App Store. And our SDKs and plugins will automatically handle synchronization when the clients later connect. So they can just get the data that gets pulled down. We even give you controls over the reachability client from a programming standpoint. So you can make synchronization happen only over Wi-Fi rather than just Wi-Fi and carrier if you do see so fit for your business. We also give you some other things in the SDK and the service. And one of them that's quite interesting from a client-side perspective is this concept that we call complex objects. And the traditional pattern when it comes to storing content like images and videos that you want to list out from a database perspective and put in your application is to usually store these in something like Amazon S3, and then maybe put the records in a database like DynamoDB, but do it so that rather than storing the images in Dynamo, it's pointing to the location in a bucket, kind of like a file pointer, if you were to kind of conceptually think about that. And the classic use case for things like this is I might want to create an application that has profiles. And profiles, of course, will have first name, last name, integers for age, and things like that. But I might want to also associate this with a profile pic in my app. And so what do people need? They need the ability to have that logical object and that data type, as well as the ability to like update photos and add them and read them. And this would be basically an input type that you would do. And how we handle this is you can add into your GraphQL schema a S3 object type and specify the bucket, key, and region. Just logically, it has to be specified here. And then you create a S3 object input type. And basically what we're doing is the profile pic is pointing to this specific S3 object in your schema definition language. And then the S3 object input is part of the input for your mutations. And behind the scenes, what happens is when you call a mutation for one of these S3 types, we'll send the write-off so that the record goes into the database. And then the SDK will actually upload the data using the S3 endpoint behind the scenes for you. So your images or videos will get uploaded there. And then upon completion on that upload process, the record will be confirmed in the database and written so that it's pointing to that location in S3. And the reverse process is essentially happens when you want to do a query to get data from a complex object or list all of them. And this even works with like the S3 accelerated endpoints if you want to do that. So you get all the power of the AWS cloud without the client developer having to think about, okay, now I'm writing and reading content from S3 and going to AppSync. Instead, it's just a single interface for all of your application data, whether it's the traditional data types that would go into a database or more of the rich content that might go into a bucket like S3. Now, finally, let's talk about GraphQL subscriptions and the real-time data, right? So we focused on the service, how to build things, how to do things offline, and so forth. GraphQL subscriptions give you this real-time database type feature and just kind of real-time data in general. So subscriptions as a spec are defined are quote-unquote near real-time updates of data. What this means for AppSync is it's actually a WebSocket connection that we manage for you that you can send notifications of data changes down to those clients. And it's an event-based model, as I showed you in the demo earlier and some of the schema definitions, to where you use that annotation to specify what mutations are going to trigger a subscription notification. The important thing about this is because you're using AppSync with this pipelining model, you can make any one of your data sources inside of AppSync, including Lambda functions that speak to other AWS services, real-time. So it's not just restricted to one specific area. And so you can see in this little workflow that I've got on the screen, if I kicked off a mutation to do an add post with an ID of 123, title of new post, author is Nadia, on the right-hand side, that specific client is subscribing to add post subscriptions. And so that client will get that notification of that data. Our SDK handles everything for you of merging it into the normalized cache and then persisting it to disk. So you just need to write a GraphQL subscription. You don't need to worry about updates or deltas of data or anything like that. We automatically merge it into the store for you. The way this is done is through those schema directives that I showed you earlier. So let's walk through a use case in a little bit more detail. So in this case, what I did is I created mutations. I created add post and delete post. So I want to have my blog post system real time. For adding posts, I'm going to pass in the ID and the title and things like that. Return an individual post, and delete post, all I need to know is the ID, right, to delete it. But I want to also subscribe to any of these events from my clients. So on the client code, and you can actually see how these relate to each other. But on the client code, what I'm going to do is I just want to know about, on my specific client, subscriptions to new posts. So I in my client code in using Apollo, I would do subscription, new post subscription. That's just the friendly name I give it. And then I say, I specify the added post subscription. I give it the selection set that I want to come down because I want to know about the version and the title and the URL and stuff like that. This essentially is the client-side field that corresponds to your server-side subscription slot. On the client, when you do this, so that added post thing that I'm subscribing to, what it does is on the connection to a network, or if you invoke a new subscription from your code, it will do a subscription call to the AppSync service. Our service will do the authorization checks and the negotiation, and it'll return back to the client WebSocket URL as well as the connection payload to subscribe to those specific topics. Then the client, and part of our Handshake process of our plugin to this for our SDK, will initiate the WebSocket connection back to the service, and it'll persist it until the client goes offline again and handle the reconnection of the topics and so forth from there. Now, you could just simply subscribe to some real-time updates if you wanted to do that. But the real-time subscriptions also play a role in getting the real-time updates to update your optimistic UI as well. And previous to what you saw before when you were going to make offline changes, if you wanted your UI to get insertions of new data as they come back, we have SDK examples of this, and part of our programming model to where you basically pass that information into one of your views. Again, similar to the other code I showed before, this is specifically JavaScript with React, so this comes back via props in this subscribe to more prop. And you pass in the subscription data, and here I'm using that new post again, and your UI automatically gets updated from there. Okay, great. Back in our console, we're going to look at a real-time example, and if we look at this specific API that I've got, I actually called this one Weekend Plans. And it's using the built-in sample that I showed you earlier. So this is the built-in sample that you can find in the console that has events and comments on those events with mutations. And it is already using the AWS Subscribe capabilities to comment on a specific event. From a client perspective, what you would see is a project similar to this if you download the sample starter application. I'll make this a little bit bigger. And you can see it is standard React Apollo that I've pulled down. I've also passed in a few things, such as my all events and new events components. And for GraphQL, right, we mentioned earlier, and you saw the demos, the client defines what data it's going to pull down over the network. So, for instance, the client wants to query all events. It is just a GraphQL query that I'm running here locally that I'm passing. So it's traditional in some of the JavaScript frameworks to separate these into separate files. You could have that in your main.js file. It's kind of up to you. The point is that it's actually on the client side that I'm specifying what specific data I wanted. So if I wanted to get a specific event, but I didn't want to know like the when and the where, I could simply just delete that, and I wouldn't need to return that data from the client if that was the route I wanted to go. Similarly, I'm going to subscribe to some of those events because, as I mentioned, I wanted a real-time subscription. So my client's actually doing a subscription to this new event, and I want to get back the event ID and comment ID. When it comes to our AppSync client, it's a similar constructor that you saw before. In this case, I'm using my API key, and I'm taking this client and passing it to React Apollo as the provider. This is really all you need to get going. So I'm going to go ahead and start this app up. And it is refreshing. And the reason that I'm showing this side by side is for a couple of reasons. One is I want to show you just kind of the functionality of things as I can add new events. So before I created this webinar one, and this had a little nice state picker and things like that I added a comment on before. But let's say that I wanted to call this dinner with Mary. And I wanted this to be, the end of February, and I wanted it to be in New York City. And I saved this. right? Now, I've got these two pieces of detail over here, but I don't have this on the left-hand side because the only subscription I had was set up was to get subscriptions in real-time events to only the comments on events, not as new events were coming in. So again, this is developer controlled, but if I refresh it, you can see I've got Dinner with Mary over here. And I can click on some of the data here and I can add comments. But I did, in my app, subscribe to comments on new events. So I could do things like, sounds fun, add this in. And because this is a WebSocket connection real time, it's actually going to show up. And this was actually end-to-end latency that you saw in that demo, right? So I've submitted a mutation for adding a comment to the service. It went through the service, went through the entire conflict resolution process, and it came back to my client from the cloud back to it to give it some more information. I show these side by side. I can go the reverse way. Right, so I get real-time data back and forth, and of course this works across the multiple platforms that AWS offers AppSync SDKs for. All right, now that we've demoed the service as well as some of the client capabilities in real-time pieces, just to wrap up, a few best practices that we always encourage people to look into. Right, so you can see this is a pretty powerful service when it comes to just general data fetching, but as well as offline capabilities and real-time subscriptions and so forth. But the first thing is, offline is important, but there's a little bit extra, work that you might need to do if you want to do mutations offline, because as you saw, it is developer controlled. So maybe you don't need all of your views updated when you do mutations, or you know what? Maybe you just need data readable when it's offline, like it's a news story app, or it's some other thing that you're pulling data from your data lake, or you're doing some sort of global event sourcing. So just start easy. Just invoke the SDK with the constructor and just start offline for queries and see where you go from there, right? The other thing is use the subscriptions appropriately, like I showed you, right? You don't need to send all data over a real-time channel. Large paginated data that's coming back, first of all, AppSync handles the pagination for you, but secondly, there's a reason why there's a request response channel and a subscription channel. Use a subscription channel wisely for smaller updates, deltas, and things like that, because this will really matter in your application lifecycle when it comes to the battery and the CPU and just the general network performance and snappiness. The other thing is, we didn't go into too much detail today. By default, there's a bunch of conflict resolution, but do you actually need complex conflict resolution? AppSync gives you a lot of power and capabilities for this, such as custom logic in the cloud, but only go that route if you really need it to be. You might just want to use the default built-in methods of, last write wins to the service. Otherwise, then you can kick off custom Lambda functions. So make sure to do it if it's appropriate and if it's actually necessary. So with that, I want to thank everybody for attending today. And if you have any, further questions, please ask us, in not only the comments on this webinar, but also, in any of our forums or our GitHub locations. Otherwise, please go to the AppSync website today and give it a try and let us know what you think. Thank you.